An Sn2 reaction is a nucleophilic substitution reaction with second-order kinetics. In a second-order or bimolecular reaction, two reactants come together in the slow or rate-determining step of a reaction. In a nucleophilic substitution, these two reactants are a nucleophile and an electrophile. A nucleophile is an electron-rich species which donates an electron pair to the formation of a bond. An electrophile, and more specifically the electrophilic center, is electron deficient and accepts an electron pair in the formation of a bond. The electron deficiency is often due to the presence of an electronegative atom. In an Sn2 reaction, the electrophilic center is saturated. Therefore, the formation of a new bond requires the breaking of an existing bond. Thus, the electrophilic center must be bonded to a leaving group. The leaving group is typically the atom or group of atoms which cause the electrophilic center to be polarized in the first place. At the same time that the nucleophile bonds to the electrophilic center, the bond to the leaving group is breaking. Bond making and bond breaking occur in a concerted manner and along a linear orientation. The nucleophile attacks the molecule from the side opposite to the leaving group, and the reaction causes an inversion at carbon. Key terms include concerted, backside attack, inversion, one-step mechanism, and steric control. This view is a planar representation of an Sn2 reaction, as it might be drawn very simply. The nucleophile is hydroxide, with the electron-rich oxygen being the nucleophilic atom. The electrophile is methyl chloride, and the reaction center is the saturated electrophilic carbon. The chlorine is the leaving group. The middle panel shows the essence of the one-step mechanism and the flow of the electrons. Hydroxide attacks carbon from the side of the molecule opposite to that bearing chlorine, and as the bond between oxygen and carbon forms, the bond between carbon and chlorine breaks. The bottom panel shows the product methanol with inversion at carbon. Note that the leaving group has formed as a new but weaker nucleophile, chloride. This is similar to the reactivity of acids insofar as the reaction of a strong acid results in the formation of a weaker acid if the reaction is favorable. In motion, hydroxide attacks carbon from the backside of the molecule relative to chlorine, and as the new bond forms, the bond to the leaving group, chlorine, breaks.